Hey everybody, it's Dave here. Welcome back. In this video, this is the video for chapter 1.2. We're going to talk about mathematical models that we see in finance and in business. I've divided the video into 4 parts. We're going to look at supply and demand. We're going to look at depreciation models, followed by cost, revenue, and profit models. And then we're going to look at these in a quadratic context, and I'll explain what that means. I'll see you on the next slide. So the first model we're going to look at is a model of supply and demand. And what this involves is when you have a product that you're trying to sell, this involves trying to find the right price point for that product. Now, there's always 2 sides of selling something. You have what the company wants and you have what the consumer wants. So the supply side, that's what the company wants, and the demand side, that's the consumer side. So let's look at the supply side first. And we're going to draw a graph, and we're going to do these as linear models. So everything's going to be a line for the first part here. On the x-axis, we're going to have the number of units. So think about that as the number of iPads that they're selling or the number of cell phones. And on the y-axis will be the price. So we're going to create a curve that kind of models the general trend for supply and demand. So the company, if the price is really low, they generally don't want to sell too many products. So you're going to have a low point here. But if it's at a high price, ideally they would like to sell a ton of them at high prices. So the curve, it's a line, the curve would actually have an upward slope like this, the supply curve. Obviously it won't go into the negatives there, but it'll have an upward slope. All right. Now on the demand side, as consumers, if we're trying to buy a cell phone, at a high price, we're not going to buy that many of them. But at a low price, so if the price were low down here, we're going to buy a ton of units. We'll have a large X value. So our curve will generally be a decreasing linear line here for demand. Now the interesting thing comes when we put these 2 things together. So we look at the balance between what the company wants and what the consumer wants. So if you plot these 2 graphs on the same, of the 2 lines on the same graph, they're going to intersect at some special point here. And this point is called the equilibrium point. All right? And so what it represents is really the ideal price for setting this product to be sold at. If you look at the X value at this point and the Y value at this point, that tells us a lot of important information. The Y value is the equilibrium price, and the X coordinate is the equilibrium quantity, i.e. the number of units that you would sell at that equilibrium price. And that's the best place to fix things, to fix that price. So what we're actually going to do is we're going to see this in an example, and we're going to look at this example I've kind of made up about iPhones. So we're going to read through this and decipher it, but we're going to be given information about the supply, what the company wants, and information about the demand, what the consumer wants. And we're going to circle all that. So it says the quantity demanded each day of the new iPhone is 1,000 units. So we have 1,000 units when the price is $700. That's an ordered pair. The quantity is 1,000 and the price is $700. So that's an ordered pair that will live on the demand line. Then I have 500 units when the price is $950. So that's going to be an ordered pair with 500 units at $950. So those 2 ordered pairs are going to live on the demand side of the curve. For supply, the supplier wants to sell $250 when they're priced at $600. So you'll have the ordered pair $250, $600. And then it's going to be priced at $1,100 when they sell $1,250. They want to sell $1,250 when priced at $1,100. So you'll have another ordered pair given here. So I'm going to pause the video and write this under each category. So we have 2 ordered pairs for supply, 2 ordered pairs for demand, and now I want to find an equation. Now remember, the supply line is a positive sloping line, and the demand line is a negative sloping line. And we have 2 points that live on it, so we just need to find the slope first for each. I'm going to do that on both sides, and then we can find the equation with things we learned from our algebra review. So let me pause and use the slope equation. And you can see here I've used the equation for slope, y2 minus y1 over x2 minus x1, and I've gotten a slope of 2 for supply and minus 1/2 for demand. Now we can use our formula y minus y1 equals m times x minus x1 on each side, and you can just pick your favorite point. I'm going to pick this as x1, y1, and I'll pick this as x1, y1 for demand. All right, and I can write my linear equation for each. And you can see what I've done here. I've inputted the points as well as the slope, and then I've solved it to be in slope-intercept form on both sides. So you've got your demand equation, your supply equation. That was the first part of the question. The next part actually asked us to find the equilibrium quantity and price. And what we need to do for that is actually set these two equations equal to one another. So we're going to algebraically set these equal and then solve for x. And you can see what happens here. I've set the equations equal to one another. You can bring this x term over here for 5/2, and you subtract 100 from both sides to get 1100, and then you can solve for x. So again, if you're having trouble with these algebraic steps, I don't want to spend a lot of time in these videos on that, but please see me in my office hours or shoot me a message and we can talk more about that. But you're going to find that you get 440 units, or iPhones in this case, as your answer. That's the ideal equilibrium quantity of iPhones sold. To get the price, you need to take that 440 and input it back into either equation, either this equation here or this equation here. It's completely up to you. And so I just use the easier one, so I'm going to say y is The next model we're going to look at is a model of depreciation. So what this actually allows us to do is track the value of something we purchase as it continues to get lower and lower after the purchase date. So the best way to think about this is to imagine buying a car. So you walk into the car dealership, the time is now, and you buy this beautiful car. Okay. Now originally it has some purchase price. We're going to call that value V. You walk out, you drive it off the lot, and that value is going to start to depreciate. So if you think about the curve, and if we're going to assume a linear model, we're going to assume linear depreciation, and over time that's going to depreciate until it's worth nothing. This is the depreciation model for the value of this car, and we're going to try to find equations for this for certain situations and do a few examples involving this. So V is now the value, T is the time. So let's check out an example of this depreciation idea. And let's suppose John went in and bought a RAV4 a couple of years ago for 20 grand. What we're going to do is actually start to find ordered pairs that represent this situation, and the x is going to be really time, and the y coordinate will be the value. So the first is going to be in years, and the value will be in dollars. So when he first purchased it, we're going to let that be time t equals 0, and it's going to have a value of 20,000. It explains that 2 years later, the value of his car is estimated to be 14 grand. So we now have an ordered pair of 2, 14 grand for the depreciation. Assuming that this is linear, so we're assuming it belongs on a line, we want to find an equation. And to do that, we first need to find the slope of the line, and the slope is going to be the change in the value, so that's 20,000 originally, and then now it's 14,000, divided by the change in time, a 0t originally, a 2 time here. So that's 6,000 divided by -2, which gives us a slope of negative 3,000. Once you have the slope in your back pocket, you can use point-slope form to find the equation. Now, point-slope form is here, but remember, our y is really v, and our x is really t. And so you need to pick one of your ordered pairs to use. It doesn't matter which one. So, if you use v1 and t1, this would be your initial time, t1, and this would be your initial value, v1. So we can input those. The initial value was 20 grand. Again, my slope we found to be -3 grand, and my initial time was 0. And we'll express the final value in slope-intercept form, so I'll add the 20,000 to both sides, and there's your final equation that represents this depreciation. One cool thing we can actually do with this is we can find out when the value is going to be equal to 0. And that's pretty cool for John to know, because he'll know when his car is actually worthless. So you'll set this value equal to 0, and you'll solve for time. And so that's a pretty simple algebraic thing. You're going to find that this is actually equal to about almost 7 years when his car will have no value. So of course that's not really true, but if we did have this trend and this depreciation, that would be the fact. The next model that we're going to discuss involves cost, revenue, and profit. And these models, again, we're going to consider them as linear models, and they'll focus mainly on the company's perspective. So suppose you're creating a product, let's say iPhones again, and we're creating, let X be the number of units that the company is creating and selling. There's going to be a cost associated with creating those products. Now for the company, there will be a variable cost that will depend on how many iPhones they're actually creating. So generally, there'll be a quantity, we'll call it M, that will represent the cost to create one phone. So if we're trying to find the total cost for them to sell X phones, you'll multiply M by X. And let's suppose this is every day. There will also be a cost associated that we call a fixed cost, and that's associated with running the warehouse, with turning the lights on and hiring, some basic employees. And we're going to let that fixed cost be given by a quantity B. So ultimately, your equation for C, the cost, will be mx plus b, mx being the variable and b being the fixed cost. Now, once the company decides to sell that product, they're going to create revenue from selling that product. And the revenue depends on how much they sell the product for. So if you sell 50 phones for $1,000 a piece, you're going to make $50,000, and that's the company's revenue. So the revenue R will always depend on the price, which we'll call P, times the number of units that they sell. So R is actually equal to P times X. Finally, from on the profit perspective for a company, they're going to take the revenue, that's the money coming in, and subtract the cost, which is the money that they have to spend. So a company's profit is R minus C. And we're going to see this in action in some examples. Before we get into a few examples, there is another term that I want you to be familiar with. It's called the break-even quantity, and it's pretty much what it sounds like. So a company, they're going to spend a certain amount of money, then they're going to sell their product, and they're going to make a certain amount of money. And the profit will be money in minus money out. When the company makes $0 profit, that's what we call the break-even quantity. That's a bare minimum. If you have a negative profit, that's not good. Even breaking even is not good. You obviously want positive profit. But it's important to be able to find that quantity. How many iPhones do I have to sell to break even? And so to do that, you set our profit function equal to 0, or you can set the revenue equal to the cost. And then you solve for X, which is your number of units to break even. All right, we'll see this in an example. So sticking with my Apple theme, suppose we have a factory that produces iPads, and there's a fixed production cost of $2,000. So remember, that's what we called B on the last slide for my fixed cost. That's B. And the marginal production and distribution costs are $150 per iPad. So marginal is another word that's used to discuss the variable costs. So this 150 is actually that M value that we talked about in the cost function. The iPads are then sold for $300, and that's going to be your price that they're sold for. So we want to find the linear cost, revenue, and profit functions where X represents the number of iPads that are made and sold each day. So this is an assumption that we make. We assume that all the iPads that are made are actually sold. So that means X, our quantity, represents both the number made and the number sold. So let's go right ahead. Our cost, C, is a function. It's going to have variable costs of M, which is 150, times the number of iPads I sell, plus B, which is 2,000. So there's my cost. My revenue is just P, the price that we sell the iPads for, times the number that I sell, which is X, and my profit is revenue minus cost. Revenue is 300X, and cost is 150X plus 2,000. Notice my use of parentheses here. That's super, super important. These parentheses, if you forget them, then you're not going to be distributing that negative as you should be. So when I distribute this negative sign, it goes to both terms, and you'll actually end up with 150x minus 2,000 for your profit function. And I don't know if you noticed on the last slide, but I like to write this as a capital P. So I put a little line under it so that we don't confuse profit with price. And that would be our profit function. The next part says, what profit or loss results from the sale of 200 iPads? So what we're going to do is we're going to take our profit function and evaluate it at 200. You'll notice oftentimes I suppress the X when I write the P or the R or the C, and that's just natural, that's convention in mathematics. But if you're going to evaluate at 200, we'll write it in this functional notation. So you basically just input 200 for X, and then you check out what's actually happening here. So you multiply 150 times 200, and then you're going to subtract 2,000. And you'll find that your profit is actually $28,000. And finally, the last part says, what is your break-even quantity? So remember how to do this. This is when your profit is 0. So we're going to set P, the profit, equal to 0. And my profit function is 150x minus 2,000. Set that equal to 0, so we slide the 2,000 to the left, and we divide by 150. So you'll have 2,000 divided by 150. And we quickly find that the break-even quantity is just a little over 13 iPads. So as long as they make 13 iPads a day and sell 13 iPads a day, they are going to turn a profit. In the last part of the lecture here, the lecture video today, we're going to actually talk about quadratic models. So what we've done so far is we've only looked at lines. That isn't always the case with models of cost, revenue, profit, supply, demand, etc. Sometimes we'll have quadratic, which means that you have a square on your independent variable. So the general form for quadratic is up here, ax squared plus bx plus c. These will look like parabolas. So when I say quadratic, just think parabola. And parabolas can either be downward facing or upward facing. They'll be downward facing if that initial, the first constant there, the a, is negative. So if you have a negative a, you're going to have a downward facing parabola. If you have a positive a, you will have an upward facing parabola. Nonetheless, in our applications, which we'll see on the next slide, it's super important to determine where that vertex is. That's going to have a meaning, a very practical meaning in these business contexts. And to find that vertex, we have an equation here, which I'll circle down at the bottom. And this equation will help us find that vertex. You'll always be provided with this equation, but it is important to understand how to use it from the original form for the parabola. Oftentimes, I get the question from a lot of my students, and they say, well, why are we doing linear stuff? And then all of a sudden you say, well, I want to do some quadratic stuff. There's a reason. Demand, the demand of a product, that's what the consumer wants, is often linear. And we talked about this at the start of the video, that a lot of times, at higher prices, you're going to get a lower demand of a product, and at lower prices, you get a higher demand. So the price, when we set the price, it often has a linear form with a negative slope. It's going to have a negative slope to it, but it's linear. Okay? Revenue, so in terms of what the company is pulling in, the revenue, as we discussed earlier, is the price that they're selling the units for times the number of units that they sell, times X. Well, if the price, the demand curve, is linear, and then you multiply by the number of units, you'll end up with a square on your X, which means that revenue will actually be quadratic. And the same can be said in context with cost and so forth. It'll be quadratic, and it will have a negative slope, a negative initial quantity there, initial constant. And as I told you on the last slide, that means it's going to be downward facing. So oftentimes our revenue curves will be parabolas facing in the downward direction. Why is this important? Well, in our business contexts, we care about revenue, companies care about revenue, and they care about maximizing revenue. They want the most amount of money coming in. Well, they actually really want to maximize profit, but nonetheless, whatever the quantity is they're trying to maximize, they want to know the highest point, and that's represented by this dot right here. That's the vertex. So if we know how to find if we have a revenue model that is quadratic, and we know how to find the vertex, we can determine the number of units that we have to sell in order to maximize our revenue. And that's exactly the type of examples that we're going to do. So let's see how this works in an example for using a quadratic model. Suppose that we have a demand function for a TV, and the demand function is given by 200 minus 20x. So that's the price. P is price, and x is number of TVs sold. Remember the revenue, so the first question says find the revenue function. The revenue function is simply going to be P times x, where P is price. And now P is given by 200 minus 20x, and we multiply that by x. So we actually get 200x minus 20x squared. And there's our quadratic model. Just for simplicity, I'm going to rewrite this as minus 20x squared. I'm going to put the x squared term first plus 200x. And remember, there's a 0 after that. So when we're using the quadratic formulas and things, that last value would be a 0. I'm not going to write it, but just remember that there is one. So that's the first question. We got that first part done. Determine the number of TVs that should be sold to maximize revenue. So what you want to do there is you want to find the vertex of this parabola. Remember that this is a quadratic. It's got a negative first constant, so it's going to have a downward facing parabola, and that vertex is going to represent the maximum revenue. So we want to find that vertex. What you have here, your A value and your B value. So my A is negative 20 and my B is 200. And remember, we have a formula for the vertex. The vertex is minus B over 2A, comma C minus B over 4A. I apologize, that's actually B squared. So all you need to do is input all of our quantities, and like I said before, the C is actually 0 in this case. So we have to input all of our quantities into this formula and then compute where our vertex is. And once you kind of chug through that computation, you'll get 5, 500. And what does this actually mean? Well, this is the number of units. The 5 is your X value. That's the number of units that will maximize revenue. So we need to sell 5 units to maximize the amount of revenue that's going to come in. And the 500 will actually represent the maximum revenue. All right, and let's just talk through kind of why this is the way it is. Notice that the demand function is changing. So my price, as the demand goes down as the price goes up, and vice versa. So if I sold more than 6 units, then I'm going to sell less, which is going to cause me to make less revenue. So this is the sweet spot, per se. If we sell 5 units, we'll make the most amount of money. And that's all I have for you guys in this video. I'll see you next time. Good luck practicing. Let me know if you have any questions.